Okay, so let's talk about a riddle. This is one of those puzzles that sounds completely, utterly impossible, even after you hear the solution. It's a fantastic puzzle about life and death, but it's really about probability and a kind of hidden structure that can turn what looks like certain doom into a real shot at freedom.
So, put yourself in this situation. You're one of 100 prisoners on death row. Your life and the lives of 99 other people all hinge on a game of chance. It seems hopeless, but what if there was a strategy? A hidden key to unlocking the whole puzzle? All right, so here are the rules of the game. You've got 100 prisoners, conveniently numbered 1 to 100. In a separate room, there are 100 boxes, also numbered 1 to 100. Inside each box, there's a little slip of paper with a prisoner's number on it. The numbers have been put in the boxes completely at random. Now, one by one, each prisoner goes into the room and gets to open 50 boxes, just 50, to find the slip of paper with their own number on it. And here's the kicker. Every single prisoner must succeed. If even one person fails to find their number, everybody fails. They can all agree on a strategy beforehand, but once that first person walks through the door, it's total silence, no communication.
So, what's the first thing that comes to mind? Well, you'd probably just have each prisoner walk in and open 50 random boxes, right? I mean, you're opening half the boxes in the room. That gives you a 50-50 shot, which sounds okay, I guess. But what are the odds that everyone pulls it off?
Yeah, the odds are not great. The probability is 1/2 multiplied by itself 100 times. That number you're looking at right now is so vanishingly small, it's basically zero. I mean, it is a practical impossibility. It's a guaranteed execution.
But what if I told you there's a strategy, a simple one, that takes their chances from absolute zero to over 30%? That's not a typo. We're talking about an improvement of 30 orders of magnitude. This isn't a trick, it's just really, really cool math. And the solution isn't some ridiculously complex algorithm. It's an incredibly simple procedure, something anyone could follow. And the result? Well, it's just astonishing. Okay, you ready? Here it is. It's called the loop strategy. Every prisoner enters the room and does the same thing. First, they open the box that has their own number on the outside. So prisoner number 73 starts by opening box number 73. Inside, they find a slip of paper. Let's say it has the number 24 on it. So what do they do next? They go to box 24. They open it, find another number, and go to that box. They just keep following the chain of numbers from box to box. And just by following that one simple rule, their chance of survival skyrockets to about 31%. I know, it sounds like magic. How could this possibly work? How does such a tiny change in strategy produce such a massive difference? Well, the answer is hidden in the way the numbers are arranged. To really get why this strategy is so powerful, we need to stop thinking about a room full of random boxes and start seeing what's really there. A hidden structure of chains, or what mathematicians call loops. You see, because every number from 1 to 100 is in exactly one box, pointing to another box, the numbers automatically form closed chains. Think about it. Box 7 might have a slip that points to box 42. Box 42 might point to 91. And box 91 might point right back to box 7. Boom, that's a loop of length 3. The entire room, no matter how the numbers are arranged, is always made up of these loops. And here is the absolute genius of the strategy. When a prisoner starts by opening the box with their own number, they are guaranteed to be on the one and only loop that contains their number slip. They can't be on the wrong path. Their number is definitely 100% somewhere along the chain they're following. So this means the fate of every single prisoner comes down to one simple condition. A prisoner succeeds if the loop they're on is 50 boxes long or shorter, because they have 50 tries to follow it to the end. But if the loop they're on is 51 boxes long or 52 or more, they will run out of chances before they find their number. And here's the catch. If one person is on a long loop, everyone on that long loop will also fail. Their fates are linked. So the whole giant problem of 100 prisoners and 100 boxes just collapsed into a single question. In a completely random arrangement, what is the probability that there are NO loops longer than 50? And believe it or not, the math for this is really elegant. The math is actually pretty beautiful. It turns out that for any given length, let's call it k, the probability that a random arrangement of numbers will have a loop of exactly that length is just 1 divided by k. So the chance of a giant loop of 100 is 1/100. The chance of a loop of length 78 is 1/78, and so on. Simple as that.
So to figure out the total chance of failure, we just need to add up the odds of any losing loop existing. That means the probability of a loop of length 51, plus the probability of a loop of 52, plus 53, and so on, all the way up to 100. And when you add all those little fractions together, 151 plus 152 plus 153, you get a number that's really close to 0.69, a 69% chance of failure. And if the chance of failure is 69%, well, the chance of success is just everything that's left over. 100% minus 69% is 31%. And there you have it. That's where the number comes from.
But the math is one thing. The real genius of this strategy isn't just about the numbers. It's about a complete shift in perspective. It's about shifting from individual chance to a kind of shared destiny.
Think about it like this. The random strategy was like 100 separate coin flips. One person's success had absolutely no bearing on anyone else's. But the loop strategy is brilliant because it ties everyone's fate together. The success or failure of the group is decided by the room itself, by the length of the loops, before anyone even takes a single step. They will either all win or a huge chunk of them will lose, together. What this means is you can't have a situation where, say, 99 prisoners find their number and just one poor soul fails. It's impossible with this strategy. About 31% of the time, the room is in a winnable state and every single prisoner finds their number. But the other 69% of the time, there's at least one loop longer than 50, which means every single person on that loop, at least 51 people, is guaranteed to fail. It's all or nothing. And here's maybe the most mind-bending part of all. What if you had 1 million prisoners and 1 million boxes, and they could open 500,000 each? You'd think their odds would drop to 0, but they don't. As the number of prisoners gets bigger and bigger, heading towards infinity, the probability of success actually settles on a fixed number, 1 minus the natural log of 2, which is about 30.7%. Isn't that incredible?
So in the end, the prisoners found a way to win by tying their fates together. They traded a series of terrible individual odds for a single shared 1 in 3 shot at freedom. It really makes you wonder, doesn't it? What other problems that seem impossible might just be waiting for a solution where we stop thinking about individual chances and start thinking about a shared fate?